Hello everybody, this is Dr. G. In this video, we are going to go over 2019 free response question number 2. This is the PVA problem, position, velocity, and acceleration problem. The velocity of particle P moving along x-axis is given by a differentiable function V of P. The unit is meters per hour. Select the values of Vp are given in the table. Part A, justify why there must be at least one time t from 0.3 to 0.8, at which V prime, the acceleration of P, equals 0. So 0.3 and 2.8. So V at 2.8 equals V at 0.3 equals 55. So the average rate of change between 0.3 and 0.8 will be 2.8 minus V 0.3 over 2.8 minus 0.3, give us 0. Average rate of change between 0.3 and 2.8. So, based on the mean value theorem, as function Vp is continuous and differentiable, so there exists at least one point t where the derivative at that point equals 0. Part B. Use a trapezoidal sum with 3 subintervals 0.3, 0.3 to 1.7, 1.7 to 2.8 to approximate this interval. So trapezoid Riemann sum. So the distance delta x 0.3, 1.4, and 1.1. So this is approximate equals 1/2, 0 plus 55 times the height plus 1/2, 55 minus 29 times 1.4 plus 1/2, negative 29 plus 55 times 1.1. And use our calculator, we get 40.75. Part C. A second particle Q also moves along x-axis so that its velocity for t is between 0 and 4, given by this function. Find a time interval during which the velocity of particle Q is at least 60 meters per hour, and find the distance traveled by particle Q during this interval. So velocity of Q has to be greater or equal than 60. So we just use our graphing calculator. You can treat t as x and plot it. And this is 60. This is VQ. This is 60. And you find the intersection A, B. So based on the graphing calculator, A equals 1.866181. B equals 3.519174. Just keep as many decimals as you can, because we are going to use this time interval to evaluate the distance. As we know the distance formula from A to B, the magnitude, which is the speed. Because this is always positive, so it's the same thing as we integrate from A to B, VQ dt. We plot this into our graphing calculator. This gives us 106.10875. Part D. At time t equals 0, particle Q is at position x equals negative 90. Use the results from part B and the function VQ from part C to find the distance between P and Q at t equals 2.8. So let's draw a picture here. So at t equals 0, P is at 0. At t equals 0, Q is at negative 90. Based on part B, the position for P at 2.8 is given by 40.75. XQ at 2.8 is given by XQ at 0 plus integration 0 to 2.8 VQ dt. Use our graphing calculator. We get 135.9377. The answer will be 45.9377 meters. So at t equals 2.8, 40.75, that's P. And Q at t equals 2.8 is 45.9377. So the distance between them will be 45.9377 minus 40.75, give us 5.1877 meters. These are all the solutions for problem 2. Let's have a look at how they graded. This part, 1 point. MVT, 1 point. 1 point here. And the 2 points. This one, 1 point. Integration speed, 1 point. Answer, 1 point. Part D, 1 point here, 1 point here, and the distance, 1 point.